Okay, great. Hi, everyone. Thanks for joining us. We're excited about today's webinar, Kubernetes for Java Developers. Raphael is your presenter today. He is the Director of Developer Experience at Red Hat, and he helps developers all over the world to be more effective at software development. Raphael considers himself a problem solver who has a big love for sharing. My name is Nikki, and I'll be your moderator today. I'm with OCI. We specialize in open source software engineering. And similar to Raphael, we also have a big love for knowledge sharing, which is what brings us here today. Just a couple of housekeeping items before we kick off. Please use the chat box at the bottom of your screen if you have questions during today's presentation. At the end of the session, I will read the questions out loud and Raphael will answer as many as time will allow for. Also note that this session is being recorded and the video will be distributed within a couple of days. And with that said, I will pass it over to you, Raphael.
Okay, thank you, Nikki, and thank you everyone who joined us, and thank you for those who will watch this video later. So let's get started. Let me start sharing my screen so you can see the presentation. By the way, this presentation here is available online. So let me find the chat box here. Okay, so if you go to this link here, bit.ly/Kubernetes-intro, you will have access to this slide. These slides. Probably you want to have these slides so you can reproduce the content or get some links that you would find usable for your own experience. So before we start, I'd like to invite everyone to join the Red Hat Developers program, where the website's developers.redhat.com. And there you can find free resources for developers, just like free ebooks. There are some links here, as I told you. If you want, again, to have access to this slide, just go to bit.ly/Kubernetes-intro. And you also have books like for Java developers, like migrating microservices to databases, microservices for Java developers, building reactive microservices in Java, and even introducing ISTO service mesh for microservices. Well, since this webinar is focused on Java developers, I like to start making a tricky question. So you all know that Java is supposed to run on multiple platforms. In fact, it does run once that you have the Java virtual machine installed. So if it's capable to run on multiple machines, or no matter if it's a Windows or a Mac or a Linux, why do you want to run your application inside containers? Have you ever thought about that? It's just like a matter of hype. Well, in fact, when we place our Java application inside containers, we have several advantages. We can think in containers just like a virtual machine, but it's much more lightweight. It still have portability across machines, but since it's lightweight with a small footprint, it simplifies DevOps practices. It's easy to create and kill a container. It's easy to deploy your application, because once that you have an image for that container, you just ask to run a new container instance and it's done. So it also helps your microservice architectures because it's easy to spread, it's lightweight, and of course it promotes isolation of process. But how do you run a Linux container nowadays? You have to use the Docker command run -d to create a detachable process and just give the name of the image, right? But that will create just a single and isolated Linux process running on a single machine. But imagine a situation where you have 100 servers. Would you do a SSH on each one of them and perform Docker run this, Docker run that? And even if you could do that, you would face some challenges. Like, for example, how would you scale those applications? How would you avoid port conflicts? How do you know that those containers are still running? How do you update them if you created 100 copies over 100 servers? How would you replace those containers from the version 1.0 to the version 2.0? So where are my containers running? So those are the kind of challenges that we have when we decide to run multiple containers. And to solve that problem is we can use Kubernetes. Kubernetes, it's an interesting word. It comes from the Greek helmsman, and it's also the root of governor. It's meant to manage applications, not machines. It's an open source project written in Go, and it's inspired on Google's experience with containers that comes since 2004. Since 2004, Google are using containers. Actually, this project is hosted on GitHub. So let me open it in GitHub here so you can have an idea. This project is on the release 1.11. It has almost 40,000 stars and almost 2,000 contributors. And if you look here at the contributors, besides Google itself, you can see Smart Claytor is a architect and engineer of Red Hat. Brenda Burns also works on Microsoft. So we have several people working on Kubernetes. So besides Red Hat and Microsoft, we have IBM, CoreOS, Pivotal, VMware. So it's a project that has attracted a lot of people, a lot of companies, there is a lot of attraction. And what we'll do is understand why Kubernetes is so popular and so powerful. Well, imagine the following situation. Each one of these small boxes here are containers. And each container will run in a node. Node, in terms of Kubernetes, is a server, is a place where you can run containers. Imagine just like a server, no matter if it's a physical server or a virtual server running in a VM, because Kubernetes can run on physical, virtual machines or in a cloud, like a private or public cloud. So suppose that you have a Tomcat application, and this Tomcat application needs to talk to MySQL. So to be able to connect, to route the request from one container to another and locate this container, there is a software-defined network inside the Kubernetes cluster. So you have several machines, each one of them can run multiple containers. And of course, to be able for one container to locate another container, there is a service layer to allow external users to access those containers. We have a routing layer. And we all know that the big mantra of containers is containers are ephemeral, which means that they can die at any moment and they can be and should be replaced by another replica. So what happens with those data? Those data, Kubernetes provides support for persistent storage. So those data can be stored outside the container. And of course, to manage all this cluster here, you can have one or more master that will control this cluster here. And of course, we can have a registry to store the image that will be used to create those containers. When I started to learn Kubernetes, one of the things that were most difficult, it's because when we worked with containers, we just had two terms in mind. We have the container itself, the container instance, and we had the image. But for Kubernetes to understand it, I think that the best way is understand these four concepts. What is a pod? What is a replication controller / deployment? What is a service? And what is a label? If you understand those four concepts, you will be able to completely understand the whole Kubernetes ecosystem. So let's start with a pod. Well, pod is a group of containers because pods is a collection of whales, and whales is the logo of Docker containers, right? So when you think about a pod, you are thinking about a group of containers. They will live and die together, and of course, they will share the same IP address, the same labels, the same volumes, the same secrets. Secrets are where we store sensitive information. And we'll talk about labels and volumes later, okay? So this is a pod. And how do I specify a pod? Well, we can use JSON or YAML files. But in this case here, I'm using YAML because the syntax is more clear. So you have a definition in a YAML file where you say that the kind of object is a pod. So you have a specification of the pod and a metadata. The metadata, it's simple. You just provide a name for the pod and a series of labels. And again, we'll talk about labels later. And then the specification of a pod is a list of containers. So you can give a container a name and the image. Of course, you can provide more things like environment variables, volumes, memory and CPU limits, but the basic is the name of the container and the image that will create a pod. But imagine, so each one of these small square, rounded square here are pods. So you can see here I have a pod with two containers, but what happens if something goes wrong with a node? Suppose that a node dies, a node is over capacity, or you have just power supply issue. If something goes wrong and this node is not available anymore, what will happen with those containers? Well, those containers that are running on those pods will be migrated to other nodes that are available. And who does that is a replication controller. So a replication controller guarantees that there are always a certain number of replicas running on your cluster. So again, how you will specify replication controller? By the way, replication controller was used in the beginning of Kubernetes, and they replaced that by an object called deployment. The beauty of deployment over replication controllers is because if you change something on a specification of a pod, suppose that you introduce a new environment variable, it will cause the deployment to replace all those replicas by the new deployment with the new environment variables. Okay, with replication controllers just controls the number of replicas. So when I talk here about replication controllers and deployment, they are more or less the same with a small difference. But let's see what's the deployment, because that's what is recommended to use nowadays. So how I define a deployment? I specify that the kind of object is a deployment. We can have a metadata with name and labels. And we specify the number of replicas and a template that will create the containers. So it will create 4 containers using a specification of the pod. So again, it's a list of containers, name, image, ports, environment variables, volumes, everything that you want to specify for that specific container, or for that specific pod, I mean, okay? So the specification of the replica is a specification of the deployment, okay? Well, what about labels? Everything in Kubernetes have a label. So you can give a label to basically anything. You can give a label to a node, you can give a label to a volume, to a pod, to a replication controller, to a service, to a secret, to anything. And what are labels good for? So imagine this situation here. I have 4 Wildfly applications deployed on my cluster, 4 different applications deployed. And to distinguish them, I can use labels. So for example, of course, I have the 4 Wildfly applications deployed, but I also have Postgres deployed, I have Tomcat deployed, I have Node.js deployed. So suppose that I want everything related to my cool application. I can use label, and that will bring me those 4 containers. Suppose that I want to know what's running on my developer and development environment. I can also get everything that contains the label env equals dev. I want to know everything that's running on production, everything that's running the version 1.0, everything that's running the version 2.0. So note that I can use a mix of labels and just look for those specific labels in my cluster. So how do I define a label? Every Kubernetes object has a metadata section. So you just place a collection of key values. Okay, so you specify a key and a value that will create a label. Now, remember that I said that every pod has its own IP address and that containers can die and migrate from one node to another. So we cannot guarantee and access the container by its own IP because the IP address of the pod will change over time, especially when you're doing a deployment that will replace the pod, or if the node crashes, it can change. So there is a concept called service. Service is just like a load balancer that uses label as a selector. So for example, we have here 3 containers, and I create a service for my application cool that's running on production. So I create a service that will give me an IP address that's fixed, and we will send the request only to these nodes. My application ICE will not receive any request because it's not part of that selector. Okay, this has a different label. And how do I specify a service? It's easy. The kind of the object is a service. I can specify a name and labels, and I have a specification of the service. So what is my inbound port and my destination port, and what are the selectors that I want to use? Okay. A good thing about services is that it provides embedded service discovery. Because since Kubernetes has internal DNS, you can suppose that you create a MySQL service. You can do a ping MySQL that will return the host, the cluster IP address for that service. And also, every other container that's created after will receive an environment variable that will have the IP and the port of the service that's being exposed. So this is you receive that for free. So some other concepts before we see it with hands-on. What about persistent volumes and rolling updates? Persistent volumes is how you store data outside the container. But let's think for a moment. In a cluster, some companies or some sysadmins can decide to store the data on a Google Cloud Engine persistent disk, or using a Gluster file system or NFS volume. That's not something that the user should care about. So the admin will provide a persistent volume, and who will use Kubernetes just claim a persistent volume. That persistent volume claim you just request, I want a volume with 1 gig of free space, and that's capable to read and write. So if a persistent volume is available to you, that will be bounded to a persistent volume claim. And then in your pod, you will create a volume that uses the claim name that you specified, and then you mount that persistent volume in a mount path. We'll see that on the demo. Okay. What about rolling updates? So imagine that you have version 1.0 running, and it has 4 replicas running. The service will send the request to these 4 pods. Remember, service is a kind of internal load balancer. So it has the label appcool version 1.0. When you request to update the version, Kubernetes creates for you a new replication controller for the new version, and then it starts to create a new pod. Note that the replication controller said that I should have only 4 replicas in my cluster. And since now I have 5 replicas, the previous replication controller kills the previous version. And then it keeps rolling. If the pod of the version 2.0 is live and well, it will create a replica number 2. And then, of course, the version 1 will delete the pod. And then we'll keep rolling until we have just one replica on the version 1.0. At that moment, the replication controller is deleted. And when the replication controller is deleted, of course, the pod dies because it's managed by the replication controller. So that's how you update the version with a 0 downtime. Okay, so let's see the following Java example. I have an application here that uses a Node.js as a front end, but the backend service is provided by Vertex. I don't know how many of you have heard about Vertex. Vertex is a toolkit for building reactive applications on the JVM. And it will just provide a hello world. So when you call the API hello and a parameter here, it will return to the front end. And then we have the guest book that will post message that will be stored on MySQL, and then get all the messages that have been posted and bring them to the front end. So what you see is something like that. So when you click on submit, it will call the hello world service implemented in Vertex that will just say hello, your name plus the name of the host, and also post a message on the guestbook service. And this table will be loaded with all the messages from the guestbook. So let's start here playing a little bit with our console. So before I start, I should mention to you that to manage Kubernetes, we use a command called kubectl. Some people call it kubectl, kubecontrol, kubectl. But with kubectl, there's something that's nice because you can specify bash completion. So you can do kubectl completion Z shell, for example, because I'm using Z shell, and that will give me bash completion. So I can do tab get pods, for example. That will bring me a list of existing pods. In this case, I have my SQL already deployed. So let's explore these pods. Let's do a describe pod, and I can ask for the name of the pod, and that will bring me all the information related to that pod. So we can see here, it's running in a namespace that I've created. What are the labels? App equals MySQL, lab equals Kubernetes lab. It has just one container running. It's controlled by a replica set. The container ID, it's a Docker. It's a Docker container based on the following image: OpenShift / MySQL 56 CentOS. There are some limits, some environment variables, and note here that I mounted the path var_lib MySQL data using a persistent MySQL persistent volume. If we go here on the volumes declared for this pod, we will see that MySQL persistent volumes uses a persistent volume claim called MySQL PVC. Okay, besides that, we can see some events. Suppose that I want to read the logs from this pod. Just like we had Docker logs, we can do kubectl logs and the name of the pod. Or I can use -f to keep following the log. So anything that happens to this pod, we will see it live. So kubectl logs give me the logs of the pod. Suppose that I want to access the pod. Suppose that I want to start a new session inside this pod. Just like I have Docker exec, I have kubectl exec inside this pod. Let me do the following flag: interactive and assign a terminal, and I want to start bin bash. That will start bin bash inside my pod. So cat etc Red Hat release. I'm inside CentOS ps axu. I have MySQL running. I'm inside the pod at this moment. Of course, I can kill the pod, but before killing the pod, let me show you something. kubectl describe pod MySQL. Look here, what's the IP address? The IP is 10.128.1.2010. Let me go inside this pod, and what I will do now is kill the process. Kill one. Let me see, probably, yeah. The container died because the process died. But if I do a kubectl get pods, I will see that a new pod have been created. Let's describe this pod here. kubectl get describe pod. In this case, the pod was restarted. Okay, so the IP address is still the same. Let's do something even more radical. Let's delete the pod kubectl, delete pod, MySQL. The pod has been deleted, and now if we do kubectl get pods, we can see that this pod is being terminated, it's terminating, and a new pod is being created. That new pod probably has a new IP address. So let's see. Remember that the end was 128, something like that. Now we have a new IP address. So we cannot access the container directly. We need to use service. So let's get a service, get services. Here I have a service created that has a fixed IP number. By the way, I can do kubectl get services or get SVC. It's the same thing, okay? If you want to know the abbreviations, you can just type kubectl get, and that will bring the list of Kubernetes objects and their abbreviations. So instead of typing services, you can just type kubectl get SVC. Okay, so let's take a look inside this service MySQL. So here we can see that this IP is fixed, and the endpoint is the IP of the pods. If I have more than one MySQL replica running, probably you would see the list of endpoints here, because it uses the selector app equals MySQL. Okay. Now let's deploy the next part of our application. How would we run a Docker container, right? Suppose that I want to run a Docker container from an existing image. I would do Docker run. It's a good practice to specify a name, right? So guestbook service. Then I would specify the name of my image and a tag, right? But for Kubernetes, you just replace kubectl, the Docker by kubectl run. The name is already the second parameter. And here you can say that this is the image, because you can also specify new things here. You can specify, for example, I want the following label: Apple app equals guestbook. The environment is production. The version is 1.0. And of course, I can specify the number of replicas also. So I want to run 2 replicas. Okay? That will create a deployment. And if we get the pods, we will see that 2 replicas of the guestbook service is being created. But remember, I need something that will balance the request or the requests to this replica. So I need to create a service. To create a service, I use kubectl expose the deployment that I've created called guestbook service, and I need to specify the port. Since this run on Wildfly, the inbound and outbound, and the port, the inbound port and the target port is 8080. That creates a service. So I can do a kubectl get service, and I will see now guestbook service with a fixed IP address. Kubectl describe service guestbook service. We will see now that it has 2 endpoints, the endpoint 128 and 129. Let's see again, with what happens if we delete a pod, delete pod, guestbook service. I have 2 instances. Let me delete this one. Now let's describe the service. I have just one until the deployment create a new get pods. You can see that's creating. Once that is ready, you will see it appearing here at the endpoint. So describe service. Yeah, now we have the 28 and 36 because the second pod is ready. So kubectl get deployments. We can see that the desired number of replicas for guestbook service is 2. Actually has 2. They are all updated and they are all, both available. So that's the purpose of the deployment. So, but you see that's I had to type, I had to remember all those commands. So it should be preferable that you specify those things inside a YAML file. So I have here in the Kubernetes lab on GitHub, I have for the Hello World service, I have those YAML files that I showed to you on the slides. So for Hello World service, I have the deployment that specify also 2 replicas of the following container exposing that port. And I also have a Hello World service that gets that uses the port, the inbound port and the target port 8080, and the selector is the Hello World service vertex. So since this deployment has that label defined, it will be able to find that service. So let's see how easy it is to create. This file is hosted on GitHub. I can do something like this: kubectl create -f. I can specify this file, and I can specify also another file here, like for example, the service file. Once that I do that, it will download, it will read the content of the YAML, and then create a deployment for me. kubectl get pods. Now I have 2 replicas of Hello World service and guestbook service. Of course, I can use scale to scale up and down. So for example, kubectl scale the deployment guestbook service. I want replicas equals 1. If we do a kubectl get deployments, we'll see that the desired number of replicas is of guestbook service is 1. If we do kubectl get pods, we just have 1 pod. The previous pod died because we specified that we just need 1. Okay, what about labels? I can get all. Of course, all will bring me everything. But suppose that I want to see get all where the label is equal app equals MySQL. That will, of course, will bring me services, pods, and pods, deployments, replica certs that is related to MySQL. Or suppose if I do a get pods and I have several things, I want to see every pod that has the version equals 1.0. In this case, just the guestbook service. Or I want to see everything that's related to hello world service vertex. That's the label that I've specified for this application. So I can use label for that purpose. Okay, so this is the basic of Kubernetes. But let me show you something also that's also very interesting, which is OpenShift. OpenShift is a platform as a service from Red Hat that runs on top of Kubernetes. So everything that we saw, it's here. We have a MySQL application, we have the Hello World service with 2 pods, we have the guestbook service. When we have for the guestbook service here, the service specification that goes from the inbound port to the target port. The same here for guestbook service. If we open the service, we will see the both pods that receives the request from this specific service. We can also access a specific pod, see any environment variables, see any metrics related, for example, for memory, CPU, and network. We can access the log from the web terminal, and we can even open a terminal inside the OpenShift dashboard. And of course, we can see the events. Okay, and why I'm showing you that? Because everything that I did until now, I've used existing image that's hosted on Docker Hub. But note here on, oops, sorry, I clicked on the wrong link. Kubernetes lab. Let me go to my fork here. I have the front end, which uses Node.js, and I have a Docker file here. What is possible to do is, for example, go to OpenShift, so let me, and add to a project a Node.js application. So for example, I want to create a Node.js application. Let me, and here I can select the project. In this case, we will use Kubernetes-intro. I want to use Node 6, and I can give the application name. For example, this will be the front end. And I can specify the link for the Git repo. Okay, but remember that in the source code for my front end is inside a folder. So I need to go to the advanced option and say that the context here is front end. Okay, of course I will create a route, so I can give it any name here. I will let it create automatically. It uses the name of the application to create a route, but I could give a different host name for this route using the target port 8080, because that's the service that that's the default for OpenShift for Node. And it will also create some build configuration. I can specify environment variables that will be used by the build and runtime. I can specify deployment values. I can even choose scaling strategy. Like, for example, I want an automatic scaling. So based on the CPU request target, I can have a minimal and maximum number of pods. But at this moment, I will just create one replica. Okay, limits and also labels. So we will specify here that this is the environment is production. Okay, This is a way to do it using this dashboard. And look here, what's nice. If I go to the project, it created a deployment for the front end, but you can see here that it has a build. What this build means? It means that it will download the source code from the Git repo, and it will use a Node.js image. It will run npm install, which is just like a Maven package for Node, to download the dependencies and create a new resulting image with the Node.js runtime and your application inside it. And it will place inside OpenShift internal registry. So we'll have here image stream. In some seconds, the image will be published here. Okay, but we are waiting the image to be published. And once that the image is there, it's available there, it will create a pod with that image. So you can see here, the push was successful. So it's creating a new pod. And it also created a a route using the name of the application dash the name of the project .app.rafabene.com. So you can access that. And you can see that it's working because it read the image, the value from MySQL. So I can come here and say, welcome to this webinar. Submit. And we can see that the hello world vertex was also called. And that's the beauty of OpenShift. What else we can do? Note here that because I've used a strategy called source to image, where I provided just the source code and it created the image to me. You can see the image here. Remember that I said that it will publish the image on the internal registry. It has an object that's only available on OpenShift that's called build config. The build config, you can see that uses the source that I formed. I can specify configuration, but one nice thing about that is that you can get a GitHub webhook. So for example, I just copied this value. I can come here to my GitHub repo and add a new webhook that will send all the things that I modify on my GitHub. It will notify OpenShift in this case. So, for example, let's do a modification on the code. We can see here that we just have the build number 1. And let's open the front end, the index HTML. I will edit it straight from the URL from the GitHub and say hi. Let's change that to version 2. And for the commit message will be created version 2. Note that I just need to commit the change and GitHub will notify OpenShift automatically and start a build number 2. You can, of course, open the logs here and see that it will clone. And once that it completes this new build, it will automatically trigger a rolling update. We saw on the slides what's a rolling update. So let's wait for it. It's installing. We can see that the application that's running on production, it says just say hi, right? Now it's pushing the image. And now it's triggering the rolling update. And note that the rolling update will always keep this service available, because until the new version becomes available, what you will see is the previous version. So note here that now it's available, and now that's available, it killed the previous version, and we have the version 2 online. That's something that's really amazing to automate your pipeline or your build and send it straight to the production. Of course, you can have other kind of builds. You can specify pipelines to avoid going straight to the production, but that's something that we will not cover today. So before ending this session, let me show you something that's also really interesting, is the ability to deploy an image from inside the container. So note here that we modified the front end from the source code, and that created the version 2, but I'm also able to deploy an image that's available on Docker Hub. So suppose that I come here, specify the image, microservices dash front end, and I want the previous version, the version 1.0. So it found the image. I can create a new name. For example, I will call this as front-end v1, because that's the previous version. I can also create labels. App equals, app equals front-end version 1.0, and that's fine. Does that. When I click deploy, that will create the version 1 in a couple of minutes that will be available. Note that it also created a service. But why I'm showing you that, now that I have 2 versions of the front end running, I have a route that points just to the version 2, right? I can come here to my application route, get the route for front end, and I can modify my route to send all the requests to the version v1. And then, as v1 is not still rolling the deployment, right? So it's not available. That's why it calls it a failure. But let's return to the previous version. Let's return to the service front end and wait v1 to be available. Oh, now v1 is available. So I have v2. Let me modify the route, send that to the version 1, save, and now I will see the version 1. Note that the data is still the same. Okay, I can even come here and do a kubectl delete pod MySQL. Oops. kubectl delete pod MySQL. You see that even deleting MySQL, the data will not be lost. Another thing that I can do is create alternative service. So I can split, for example, 10% of the traffic will go to the version 2, and 9% of the traffic will see v1. Okay, so if different people access my application now, 9% will see v1 and just 10% will see v2. That's the kind of thing that that I can do with a route. Okay, and note that I deleted my SQL and the data is still there because the data is not inside the container, but it's using a percent volume. Okay, so let me stop sharing and give you guys a chance, all you people, a chance to make questions.
Great job, Raphael. Thank you. We do have a couple of questions that have come in over the course of today's presentation. The first question that we received, it was pretty early on, and the question is, are selectors always ANDed, or is there a way to OR them?
It's always AND.
Okay. The next question is, what is the right way to combine Kubernetes scalability and load balancing with cloud provider, with the cloud provider scalability and load balancing of those instances, for example, those provided by AWS?
I imagine that in this case you are talking about the load provider that it creates for EC2, where, right? It's Vladimir that asked it, right? So in this case, it's a sort of, it's more or less do the same thing, but as you could see here, when you are using, for example, OpenShift, you can do a kind of a canary deployment where you specify how many people will receive a request from V1 and V2. But the right way to combine, that's a tricky question. I would need to be more involved with this scenario to see how they can combine, because they seem to be mutually exclusive. If you are using one, you don't need another. But of course, that's a overview answer. I would need to go deeper on that. Thank you, Vladimir.
Thank you. Other questions, please feel free to type your questions into the chat box. We will wrap up here in the next couple of minutes. We have time for just a couple more. And a couple of people have asked me if this video will be emailed to everybody. The answer is yes. We will also provide a link to the slide deck to everybody who registered.
Okay, Igor asked, what about pod versioning? It's not clear what you call pod versioning, but let me try to give you the best answer. Well, you can create a version for the image. You saw that I used guestbook service 1.0, and then you can specify also a label on that pod or on that deployment. Of course, if I want to deploy the version 2, I can edit the deployment. Let me just share my screen and show how you can do that. Share screen. So for example, note here that I have for guestbook this deployment. I can edit the YAML file and specify I want now to release the version 2 based on the container 2. And of course, note here that it will try to find that image. That image is not, I don't have that tag, but the guestbook will create another deployment. And of course, this deployment will fail because there is no such image, but that's a way that you can do. So it created a pod, and probably you see it's trying to pull the image and failing. Yeah, error pulling image, failed to pull image, tag 2.0 not found, but that's a way that you can do it. Okay. So Michael asked for the link to the slides. You provided it. Clark, does this work well for the scenario? Many applications and few server. Perfect. You can, I think there is a limit by default on Kubernetes that it runs 10 pods per core. So this is the magic number. If you have few servers, 10 servers with 1 core each, it will be able to run 100 pods. But of course, you can tweak that configuration. And of course, servers nowadays have more than 1 core, but just in the case of a virtual machine.
Perfect. Thank you, Raphael. So we are right at the top of the hour and we are going to wrap up. As mentioned, everybody will receive this recording here today and we'll provide you all of the helpful links that were discussed. Please do visit our website at objectcomputing.com where you can stay up to date with all of our upcoming webinars and training events. Thank you everyone for joining us.
Thank you everyone. Bye.